In this short video, we are going to complete 22 important NEET reactions of organic chemistry, and that too in just 10 minutes. That means you will be able to secure a guaranteed 40 marks in your exams. So stay focused and let's get started. First reaction is reaction of alkyl halide with sodium in presence of dry ether, resulting in the formation of alkane. And remember, during this reaction, methane is not prepared, and then tertiary alkyl halide do not show this reaction. And remember, this is considered as best method to prepare symmetrical alkane, and this reaction is known as Wurtz reaction. After that, whenever aryl halide reacts with sodium in presence of dry ether, we get aryl biaryl compound, and this reaction is known as Fittig reaction. And whenever aryl halide as well as alkyl halide reacts with sodium in presence of dry ether, we get alkyl arene or alkyl benzene. This reaction is known as Wurtz-Fittig reaction. After that, whenever benzene is treated with RCl in presence of Lewis acid, alkyl carbocation is obtained as an electrophile, and then this alkyl carbocation or alkyl carbocation is introduced into the aromatic ring, and this reaction is known as what we call Friedel-Crafts alkylation reaction. After that, when aromatic compound, for example benzene, is treated with acid chloride or acyl chloride in presence of anhydrous AlCl3 or Lewis acid, it results in the formation of acylium ion as an electrophile. This acylium ion is introduced into the ring. This is known as Friedel-Crafts acylation reaction. After that, whenever alkyl chloride or alkyl bromide is treated with sodium iodide in presence of dry acetone, it results in the formation of alkyl iodide. Here, this chlorine or bromine is replaced by iodine, so this is simply halogen exchange reaction, and this reaction is known as Finkelstein reaction. After that, whenever alkyl chloride or alkyl bromide is treated with heavy metal fluorides, for example AgF, resulting in the formation of RF, that means once again halogen exchange has been taken place, but here chlorine or bromine is replaced by fluorine. This reaction is known as Schwarz process. And whenever aromatic primary amine is treated with NaNO2HCl or HNO2 in presence of excess of HCl, 0 to 5 degrees Celsius temperature should be there. At that time, we will get benzene diazonium salt from primary aromatic amine. Reaction is known as diazotization. But remember, this what we call diazonium salt on treatment with CuCl, HCl, CuBr, HBr, CuCN, KCN results in the formation of chlorobenzene, bromobenzene or benzonitrile, and this reaction is known as where chlorobenzene, bromobenzene or what we call benzonitrile is obtained from benzene diazonium chloride or benzene diazonium salt is known as Sandmeyer's reaction. After that, when benzene diazonium chloride or benzene diazonium salt is treated with copper powder in presence of HCl or in presence of HBr, at that time we get chlorobenzene or bromobenzene, and reaction is known as Gattermann reaction. But remember, in Gattermann reaction, chlorobenzene and bromobenzene is prepared in less yield or low yield of chlorobenzene or bromobenzene here is low as compared to Sandmeyer reaction. That's why to prepare chlorobenzene or bromobenzene from benzene diazonium salt, Sandmeyer reaction is preferred over Gattermann reaction. After that, whenever you are having benzene diazonium chloride on treatment with HbF4, it results in the formation of benzene diazonium tetrafluoroborate, which upon heating gives us fluorobenzene. This reaction is known as Bals-Schimmann reaction. And whenever you are having chlorobenzene, when it is treated with sodium hydroxide at a temperature of 623 Kelvin and at a pressure of 300 atmospheric pressure, followed by acidification, results in the formation of phenol. Reaction is known as Dow's process. After that, whenever phenol is treated with sodium hydroxide, it first results in the formation of what we call sodium salt of phenol, which on treatment with carbon dioxide followed by acidification results in the formation of salicylic acid as major product. Reaction is known as Kolbe's reaction. And whenever you are having phenol on treatment with chloroform in presence of basic medium followed by acidification results in the formation of salicylaldehyde as major product, and reaction is known as Reimer-Teymer reaction. Now, whenever alkoxide or phenoxide reacts with alkyl halide, reaction is an SN2 reaction resulting in the formation of ether is known as Williamson synthesis. After that, whenever you are having aldehyde or ketone on treatment with zinc amalgam in acidic medium, this C double bond O is changed to CH2. That means aldehyde or ketone is converted to hydrocarbon. But remember, if aldehyde or ketone is base sensitive, then this reaction is preferred. This is known as Clemmensen reduction. Similarly, if aldehyde or ketone on treatment with hydrazine in basic medium is heated and it results in the formation of hydrocarbon, that means here once again C double bond O is changed to CH2 like that of Clemmensen reduction, but Clemmensen reduction takes place in acidic medium. This reaction takes place in basic medium, and reaction is known as Wolff-Kishner reduction, and this is preferred if aldehyde or ketone is acid sensitive. After that, remember, what is Aldol condensation? Remember, Aldol condensation is basically condensation of two aldehydes or two ketones If those two aldehydes or those ketones are similar, then we call that condensation as self-aldol condensation. And if two carbonyl groups which undergoes condensation are different, they are known as cross-aldol condensation. Now the question is, which type of, say aldehydes or ketones can show this aldol condensation, which contains at least 2 alpha hydrogens? And remember, this reaction is shown by dilute base, say for example NaOH, or what we call dilute. Here it results in the formation of alpha beta unsaturated aldehyde if we take say aldol condensation of aldehyde. Similarly, if ketones undergo aldol condensation, at that time we get alpha beta unsaturated ketone. So similar type of aldehyde and ketone is known as simple or self aldol condensation. But if carbonyl compounds are different, we simply call that condensation as cross aldol condensation. After that, Cannizzaro reaction is shown only by aldehydes, and that too those aldehydes which are without alpha hydrogen and in what we call presence of concentrated NaOH. One aldehyde is oxidized, another is reduced. If both are similar aldehydes, we call that Cannizzaro reaction as what we call self-Cannizzaro reaction. We call that reaction as what we call self-Cannizzaro reaction. And remember, one is oxidized, another is reduced. Similar type of aldehyde is oxidized, similar type of aldehyde is reduced. That is why this reaction is known as what we call disproportionation reaction. But if aldehydes are different, then one is oxidized, another is reduced. Reaction is known as oxidation reduction reaction. But remember, among these two, one which gets oxidized should be that aldehyde which is more reactive towards nucleophilic addition reaction. After that, whenever phthalimide is treated with base, it first results in the formation of potassium phthalimide, which on treatment with alkyl halide undergoes SN2 reaction, resulting in the formation of N-alkyl, what we call phthalimide, which upon hydrolysis gives phthalic acid and primary amine. So remember, during what we call Gabriel phthalimide reaction, we get primary amine. And remember that primary amine should not be primary aromatic amine, because aniline cannot be obtained during this reaction. After that, Hoffman's bromamide degradation. What is this reaction known as? Whenever primary amide, whether aromatic or aliphatic, gets converted to aromatic or aliphatic primary amine when treated with bromine NaOH or bromine KOH, or we can say sodium hypobromite or potassium hypobromite. After that, we will be having another reaction that is known as carbylamine reaction. This can be also used as a test to distinguish primary amine from rest of the compounds or rest of the amines. This is shown only and only by aromatic as well as aliphatic primary amine when they are treated with chloroform KOH. They results in the formation of alkyl or aryl isocyanide. This is having bad smell. Because of that bad smell, we can distinguish primary amine from rest of the amines or rest of the compounds. Remember, Hinz-Burgess reaction is used as a test to distinguish primary, secondary and tertiary amine. During this reaction, primary amine first forms a solid which is soluble in KOH. Secondary amine forms solid, but that is insoluble in KOH or alkali. Tertiary amine does not react at all. So this was all about these 22 important NEET reactions. Thank you and God bless you all.